today. He's got over 3 decades of experience in distributed systems, embedded systems, and he's well versed in data pipelines, microservices, and infrastructure automation. And he works in Vivid Seas. Please welcome Chris Cooper. Please give him a warm welcome.
Thank you. Okay, so thanks for coming. Talking about serialization protocols, and specifically, why would you choose Apache Avro? So, for starters, I'm on the tail end of a cold. I'm a little congested still, so if you can't understand me, just let me know. I'm going to power through this. So, a little bit about me. I've been a technologist for a little bit more than 20 years. I think you said 30, so we'll say that. A variety of industries, financial, travel, row, mow, low, no so, and a lot of e-commerce marketplaces. And that's my contact info if you're interested. So the agenda for today, just to give you a quick overview of what Avro is, go into some of the details of Avro as an implementation of a serialization protocol, do some demos with it, and then talk about some of the differentiators. You know, what makes Avro different than the rest, and then you know, going through like just some modern use cases for that. So Avro is another data serialization framework, right? So basically, you know, it takes an object graph and it serializes it. It also happens to be a file format and an RPC framework. So in 2011, this is a list of serialization frameworks. There's a lot there, right? And you think, you know, why in 2011 would you create a new framework? Well, I still ask that question because there's even more frameworks today. And the differentiation between them is minimal, right? So when you're looking at a serialization framework, there are really some key features that you care about. You want it to be fast, right? If you're serializing your objects or your data out or in, speed is pretty much the #1 thing you want to look for. The second thing is you want it to be compact. So the smaller, the better, right? You know, when you have things like XML or even JSON, you know, they can get very verbose. Like the amount of information content per byte is very small. When you want to look at something like a serialization framework like Avro, you want that content to be very high. You also want it to be cross-platform and polyglot, right? The more things that you can integrate with, the better. And then schemas, right? That's we'll get into that, but basically schemas are what is actually inside of the data that's being sent across, and how do you interpret it? Okay, so as far as speed goes, if you look, Avro's pretty much right in the middle of the pack. It's about 3 to 4 times slower than the fastest serialization protocols, you know, which, you know, if you look at things like, you know, proto stuff or even just straight, you know, Java serialization, it can be pretty quick. As far as size, though, you're looking at it's right up there with the smallest, and the reason is that you know, when you look at some of the major competitors for Avro, like how many of you have heard of protocol buffers? Right. Thrift is another one from Facebook. So protocol buffers and Thrift are the 2 major contenders, I think, with Avro, and they encode a position in there. So for every piece of data, there's a 1 or a 2 or a 3, like the position, and that gets sent along with it. And that's why Avro is so small, is because it doesn't need to do that. It keeps its schema out of band. So, so when you look at cross-platform, cross-language, there's quite a few here. For the most part, most of the major languages are there. I think protocol buffers is a little bit more extreme. It's got a compiler and a plug-in architecture, so it's very easy to add plugins for new languages as they come out. So this is just an example of what schema is. So schema is basically the definition of the data format. So if you think about like a database, your table is the schema. For serialization, your schema basically can be defined in Avro in two ways, in JSON and in IDL. And the IDL is basically used to generate the JSON schema. And we'll get into it. So here's just some differences between like the JSON, protobuf, and thrift. If you look at the protobuf and the thrift, you'll see the positions that I mentioned, you know, where it's got a 1 or 2 or 3 for the field, and those things can't ever change. So your schema with those is very much fixed. You can add things to it. It's very, very difficult to remove things from it. So let's get into some of the details for Avro. So when you just declare a schema, it's in JSON, as I mentioned, and you can define it in using JSON, either using a JSON string, you know, where you name and define type, a JSON object, it's in the format type name, and then you can have any number of attributes. The key thing there is you can create your own attributes. So if you want to add some metadata to your IDL, it's a great way to add that, like documentation or anything else that you might want to store along with the schema. And lastly, you can use a JSON array, which is just a union of embedded types. Can you see this? No. So this is, I'll show it in IntelliJ, but essentially this is what the schema would look like in inside of Avro JSON format. So the schema basically has, Avro has types for that, and there's a set of primitive types, and these are defined so that you can have language communication, basically have communication between languages without losing that information. So a long, you know, is 32 bits across the board, and whether certain languages have different values for that, like a C might, or have a different definition of what a long is or representation of that than other languages, or you know, it'll make sure that it does that conversion for you. And then you can also do complex types, records, which is like C structs essentially, or you know, your Java classes. Arrays, maps, union is just like a C union. It's very powerful in that, you know, you can have your schema define multiple values in the same field and still keep it very tiny, but allow it to represent a different projection of your object in the serialization format. Fixed is just like a fixed size field, so like 16 bytes or 32 bytes, and then enum is just enumerations. So Avro serialization, basically, you can encode it in two different ways. You can encode it in binary, which, let's see if I think I have an example. So you can't really read it, but that's the binary format for Avro. So you can see, kind of look at the top of it. There is, you know, like a little bit of magic. There's the schema, and then you start seeing some of the data following that. The other format is JSON, and that's obviously, you know, readable. The difference there. Yeah, the difference there is size, right? The binary formats can be really, really compact. You can also do things with codecs on that to do like deflate it to shrink it down even further, or use Google's Snappy to shrink it down as well. Those are both supporting codecs. The other thing is every primitive type inside of Avro schema has a default sort order. The benefit there of having that standard sort order is that no matter what language is reading it or what application is reading a file, if it's different from the producer, it still can use some of the default sorting that's going on inside of that format. And oftentimes it's a lot faster to have that than it is to try to read things in and then start sorting it yourself. Here's, again, another definition of the Avro IDL. If you read through it, there's a namespace basically that just specifies, the kind of like essentially it gets mapped into a Java package. There's a protocol which is kind of like the wrapper around all of the types that are inside of your namespace. So you can see there's an enumeration, there's a fixed field there, there's a record. You tell it do some annotations in there to say like ignore the order, or to change the order from like ascending to descending. There's an MD5 in there, a union, which can be one of the two values there. An error, which is like another type of like record. And then at the very bottom, you'll see there's a bunch of methods. So Avro, in addition to being a serialization format, I mentioned that it also a remote procedure definition as well. And that, I'm mentioning it just for the sake of completeness, but it's really not a super robust implementation. You're better off looking at something that's more native for whatever language or languages you're working on. And protocol buffers, as of release 3, is probably got the best implementation of remote procedure calls out of all of the serialization formats. In fact, Hadoop, which it was kind of where Avro originated. So Doug Cutting is the creator of Avro. He also created Hadoop and Lucene. Anyone here use like Elasticsearch there's basically Lucene is kind of like the precursor for all of that, and he created it. Well, he created Avro, to help on the Hadoop format, basically between your data nodes to allow remote procedure calls to happen. And I think since that time, like Hadoop's moved away from that, and they now use protocol buffers for that as well. And Go with gRPC, which is an implementation of protocol buffers 3, is like I said, it's really powerful if you're looking strictly for some type of communication, inter-application communication. So on that note, Avro RPC, it's transport independent, so it's agnostic, but the only implementation right now is over HTTP. There's a handshaking that kind of happens, and if you're going to do that remote procedure call, you basically have to send the schema across to let it know that this is how we're going to be communicating, and can do asynchronous, but for the most part it's all synchronous. If you make the request and you get back the response. Async is basically just one way. You're making a request and that's it, and returning. So again, not super robust, but it's available. So specifically with Java, Avro has an awesome set of APIs. There's specific, what they call the specific API, which essentially is you're taking the IDL and you're using one of the Avro tools, and you use that to generate your Java classes to basically read and write from a serialization protocol. There's generic, and it's basically just a record class, and then with a set of accessors that allow you to kind of read and write data. And then there's reflection, and that's where you're taking your Java object itself and you're kind of generating the schema from that. So I'm going to step out of the presentation and going to show a couple of demos of that if you're okay with that. So, but before I do that, there's a set of tools that Avro provides to do all types of things from the command line. Reading data file to get its schema out of it. If you just want to output that and you've got a large file, to taking your IDL and generating your Java code and vice versa. If you're on a Mac, all this stuff you can install with Brew, which is pretty nice. There's also a Maven plugin that so as part of your standard build, you can use this plugin to create your generated sources for your project from IDL. And there's also a Gradle plugin as well that does a lot of the same thing with a little bit more flexibility in the configuration. So you can say, I want all the classes that it generates to have, be private or protected, and then not to generate setters for it, only getters, that type of thing. Okay, so demo. So we're going to do 3 things here. We're going to look at generating Java code from IDL. We're going to look at what it looks like from a generic API, and then reflection. Okay. Thank you. Okay, so this is an example of generic. So you'll see just kind of hard code the schema here right at the top. And then there's 3 different schemas here. And what I'm going to do is show that there's kind of a source schema, and then we can read that original schema with 2 additional schemas. So one that, so there's a person schema, and that's got all the information. It's got like a first name, last name, age, and then there's 2 separate schemas, right, where we can look at just say like the age and pull that out of that data. So, so we just have file there. So I don't know if any of these names ring a bell, but they're also in that. Here's the actual file where you can kind of see some of the data that's in there, and this is just binary format. It's not compressed. So what we're essentially doing here is I'll output like what the original writer schema is, and then we'll look at just the ages of people, pulling out the data from there, and then the names. So the key thing here is we're using Avro's generic data record. And if you look on there, there's really nothing that it's doing other than a map, right? So there's nothing in the code that is specific to the schema. You can pretty much load in any schema and start working with it as long as you know what some of the names of the fields are. And then just some stuff to go through, a generic reader, and it's just going to iterate through while there's still records, reading them in, and then outputting the age, and then same thing for name. So let's see. All right. Okay, so here basically, here's the original schema that we used. So we've got a record called person, and within this field, it's first name, a last name, and an age. And if you look, the reader schema is just has, for age, is just using the age. So it doesn't know anything about what fields are where. It just knows that it's got an age field and it's an integer. And then same thing with the person, first name, last name. And you can see it's able to read in and basically interpret the data without knowing anything about the original schema. Okay. All right, so that was generic. And next, let's see. So let's look at reflection. So Avro has been incorporated in a number of different tools. One of them is JSON. So you guys are familiar with JSON for doing your JSON object mapping. So inside of JSON, there's a data format, a binary data format library that allows you to read and write from different formats, and Avro is one of them. So, so the example here is, we just have a schema. Here, tickets, basically. It's not super important what's in there, but we're going to parse that schema, and then we're going to take a ticket object, which is just a regular POJO, and we're going to use that to basically generate the schema from that and write out the contents of the ticket. So the key thing here is this generate schema from a POJO, right? So if you look, we've got a regular JSON object mapper, except we're passing it this Avro factory. And that basically tells it, essentially we're using Avro to do our mapping to and from objects. There's a schema generator, which comes with JSON. And then we're basically just saying, generate the schema for the ticket class, and then return that schema. So, let's see. Okay. And I don't know why it's not running. Oh, I'm sorry. Yeah, here we go. Okay. So, all right, so here we go. We've outputted the original schema, and then there's also, here's the schema that gets generated from Java. And let's take a look and just do a diff between the two files. All right. Okay, so here, I'm sorry. So the last one I want to do is just showing the schema compatibility. And what this is like when you have a schema, the whole benefit here is you can take an existing schema as a source and you can evolve that over time and have a destination schema. And Avro provides this tool called, or class, basically to do schema compatibility checks. So if you don't know if you're able to read from one and be able to take a schema from a reader and read from a source, knowing what your source and your reading and your writing schemas are, you'll be able to compare the two and tell whether or not you're able to use that schema. So let's see. So here we've got a schema that we're pulling in from a file, right? A new employee schema, and then we've got this old schema that we've defined inside of here, and we want to basically test the compatibility of the new schema as a reader schema with the old schema as a writer. So essentially, you're saying can data get read from the old to new, right? Which is pretty much the use case that you're going to see in the majority of businesses is you've got some old data laying around, or it was written one way, and you've changed something in your app, and you want to be able to read that information in. The second case is like, well, let's see if we swap that around and say, you know what, I've got wrote something in a new format, and I still got this old application laying around, and I want to be able to read that data even though somebody's changed it and they've added some more fields to it. So for both of those cases, we're essentially all right, let's see. All right, I think I might have fat-fingered the schema here. All right, let's keep going. So what differentiates Avro from some of the other serialization protocols? So first thing is Avro is dynamic, and I'll get into that. Second thing is that rich schema resolution, allowing you to kind of evolve your schemas. The third thing is this, what they call the Avro object container format, and I'll talk a little about that. And then lastly, it's well integrated with a lot of the current big data tools. So dynamic, what does that mean? So Avro, Thrift, and Protobuf, they all define serialization formats using schemas. But the difference is Thrift and Protobuf can only read and write using schemas that are known at compile time, where Avro, we can deal with those unknown schemas at runtime. And I showed that with the generic the API. And code generation for Avro, it's completely optional. So you don't have to generate code from the IDL. It definitely can be faster than using reflection or the generic implementation of Avro's APIs, but it's optional. In fact, it's kind of nice not to have the IDL around if you're just doing something quick, like you have POJOs and you're just trying to read and write them out. Rich schema resolution. So with Avro, the schema is always present. The read schema and the write schema don't have to be identical. It does a projection, and if my test worked, if I didn't modify one of those files, it would have shown that you can do compatibility. And then it has that checking. So how does the Avro schema resolution work? So schema is written along with the data, right? So if the schema changes, it looks at the old and the new schemas, and then it compares the two, and then it matches them by two things. It uses the field name and the type, and that's all. So as you're going through, it looks to see, is there, from the read and write schema, do we have a field and a type that are the same? Then yes, then it considers it a match. And the rest of it will get skipped. So you can have a ton of additional stuff in there, and it won't end up getting picked up. So here's the Avro container format. So if you look at it, at the top of it is, like I said, there's a little bit of like a magic number. There's some metadata count, the schema, the codec, right? I mentioned you can use like deflate, gzip, snappy, and then there's some additional metadata. And then there's a sync block, basically saying it's the end of the header, followed by any number of blocks of the actual data. And at the top of each block is the count, and then inside of that is the number of records that are written in each. So there's some key reasons for why that sync block's in there. Objects that are stored in the blocks, those can be compressed, and they can be compressed, those blocks can be compressed independently. The sync markers that occur between those blocks, it's very similar to what Hadoop is trying to do with their sequence file. Very similar. The difference is that Hadoop sequence files aren't cross-platform, where the Avro container format, those files are. And then lastly, these files, you can store them out in S3 and AWS Athena, which is basically just like a query language like Pig, so it's based on Pig, can go through and pull all those files in and use those and query the data from those to find matches, which is pretty powerful. Yeah, so these files can be broken apart and recombined as long as the schema is the same. You're able to do a lot of manipulation with them. Yeah, so it's compressible and splittable, right? Very important when you're looking at something like Hadoop or any implementation that's doing sharding, where you're increasing the number of shards and the underlying data needs to get broken apart. Okay, Avro and Spark. So I won't delve too much into this, but Spark has a library called Spark Avro that supports your ability to load and save data frames that are in Avro. So basically it'll do the conversion for you between Spark SQL and your Avro records. Again, allowing you to use Avro files as a data source for Spark. The only thing that I will say with that is the write schema is a little bit different than the read schema, and that's because when Spark pulls that internally for the representation of those schemas, it switches around the ordering of elements. So there's some drawbacks there if you're trying to like read and write out of Spark into Avro, but it's great for reading. So another differentiator is Avro and Kafka. So all along I've been saying, that the benefit with Avro is like the schema is out of band, right? But if you're sending messages from a producer from Kafka, are you guys familiar with Kafka? Yeah. So producers producing messages, consumers consuming them. You basically would have to put the data in the schema into each message so that whoever's consuming it will know, oh, this message was written with this schema, which is definitely going to increase the size of your messages, because in some cases your schema is going to be larger than the actual message content, right? So what we'd really like to have is something that could share schemas between producers and consumers. Maybe even have like a history of schemas, like how have they changed, and then compatibility checks, right? Hey, I'm a consumer. Can I read data that's been produced with this schema? And luckily, Confluent, which is the kind of managed service company behind Kafka, has something they call schema registry. And how that works is basically the producers, when you go to serialize using their Kafka Avro serializer, you're data into a message, it goes out and we'll take that message and we'll say, okay, send the schema for this to the schema registry, and it gets back an ID. And then that ID is all that's passed along with the message. Then on the consumer side, when it's reading the schema, it gets that ID and it says, oh, this is the ID that was used to write this. Let me go to the schema registry and pull down that schema and use that schema to deserialize that message. So, so you're kind of getting the best of both worlds. It's out of band, but it keeps the messages a lot smaller, and you're able to do schema evolution. And the schema registry offers some different compatibility modes as well as some of the versioning and history. You could say you don't want any compatibility between the source and the reader schema. Forward compatibility, so in other words, newer versions of the schema will work, but not necessarily backward, the older versions will work. And then backward compatibility, the other direction, and full is basically both ways, forward and backward compatibility across schema. And with that, you basically can start enforcing some of the things that Kafka was really meant to handle in a data pipeline architecture, which is decoupling your applications that produce data from those that consume it, and not having that share that knowledge of like what created the data or how it was created or the schema that was used to create it. Where to use Apache Avro? Definitely in big data. I've mentioned Spark, Hadoop, Kafka. Data pipelines. When you're using Kafka, anytime you've got data that evolves over time, where you're not necessarily in control of all the consumers of that data, and you're evolving that schema, you want to make sure that people are still able to read that. You could even say when you're looking at like web service APIs or any type of API where you're trying to evolve some of that content, you could possibly use Avro. And of course, wherever size and speed matter, when you're serializing and deserializing data. Where Avro's not so good, I mentioned RPC. There's other things out there that are better. Also, complex object hierarchies. So Avro, when it's doing its flattening of objects, it basically uses composition. So you can take hierarchical objects and be able to reconstitute them. But when it gets really complicated, it's where it starts to perform very, very bad, and not be able to map those to a schema in a meaningful way. So again, why choose Apache Avro? Dynamic, right? You don't need to have that schema around. You can use code to generate your schemas. The schema resolution and evolution of your schemas. The container format, if you're storing large amounts of data, if you need that data able to be searched and accessed, like I said, Athena and Pig are great examples of that. And then tool integration. I listed the data tools. Spring's also got a Spring Avro implementation, and the Jackson implementation is really, really super simple to get going. That's all I had. Do you guys have any questions? Sure.
Sure. On your slide reference, Avro, I know the RPC slide or the data slide, saying that we're seeing this serialization. Is that just for RPC processes, or is that also for serialization?
So serialization is synchronous, but it's writing it one record at a time. So you're looking at like lambdas or age on 8 and 9. You can totally start basically writing or deserializing in the middle of lambdas. The asynchronous is really only for the RPC, and that is like it's like the fire and forget. You've got a message or a method that doesn't return anything, it's a void, and you just send it off and not have to worry about it. Yeah, so in fact, that's one of the benefits of Jackson, the binary data format. Is you can take advantage of all the Jackson B or annotations, as well as yes, if you're transient and not use that when serializing or deserializing. But yeah, we have Jackson annotations. You can actually change the names of some things as well. We'll introduce Jackson to generate your schemas for you.
Is there any kind of internal security to this or install
No, not security's not necessarily part of it. There's no encryption for it. I'm guessing you probably have a codec that does encryption and add that in as an extension. But yeah, right now, it's pretty much you do it like, for example, if you're storing your container files out in S3, you put the encryption on S3. But using like the file system for encryption again. But yeah, as far as like transmission level encryption, no, not part of the stack.
Confluent solution on schema registry being able to understand the evolution of the schema by presenting an ID for every schema. And in use case where you are having Kafka be a store of data, what would be the reference in regards to understanding what the schema looks like when making the call? So if I'm a consumer of data, would it be, I think you described it as an out-of-band process that would check to see if the schema is involved, and then write a third-party process to be able to query the schema registry and assume it's an API.
Yeah, it's just a REST server basically that points. You make the REST call to pull back that schema, and the Confluence implementation of their Kafka Avro serializer. There's a Kafka serializer and a deserializer. The Kafka Avro serializer implementation hides all that for you. Basically, you're just passing in the URL of the schema registry to look up, but under the covers, it's handling all of the Avro schema lookups and serialize and deserialize into your consumer objects.
Whatever message that's in Kafka partition would have to add an ID reference, correct?
Yes. Yeah. So the ID is definitely passed along with every message. That's the overhead. So but having an ID that it uses to look up versus the whole schema. Yeah. And it caches it. So once it pulls it in, the consumer's going to be able to use that for subsequent messages, relatively efficiently. It's in a case where you've got like some long-running topics, and you've got multiple things that might be writing to it, and they might be in different versions of the schema, compatible with different versions. That you want to make sure that you're able to either use the latest schema, you can force it, or use the right version of the schema for that particular message. If schemas are compatible, you can take a newer version of it, and it doesn't even matter what the producer version of the schema was, and you'll be able to read it in. If there are fields that were removed, it'll just ignore them. If there are fields that are added, one of the things that you want to make sure you do with IDL, with any type of serialization, is add default values. And what that does is, if the resolving schema doesn't have that data there, it'll know when to create reconstitutes that object, when to set those values to by using the default.
But you could set that, you don't have to do that as an IDL, correct?
No. Yeah, if you're doing the out IDL, like I said, with the schema registry, it'll generate it from your object for you. That will allow you to just have compatibility. You don't have to worry about all values or anything like that. That's it. All right. Okay. One last question.
What's the use case for the dynamic features?
For the what?
Dynamic features?
The dynamic features. So in that case, you might have a variety of different formats that are coming in, and there might be just a certain one particular field or two that you're interested in pulling out. And instead of having to worry about schemas and loading those up, you can just use, essentially it's a map. You know, here's the name and the type that I'm looking for, and pull those out kind of like quickly in real time. So,
But, I'm sorry, with that example, as far as being able to pull it out quickly in real time.
without having to have like a schema registered around, or for example, you could have even lost the original schema, and you still want to be able to pull data out of it.
I guess my confusion is, from a back-end standpoint, this is going to have to go to the store. So we're talking about big data examples, we're talking about HDFS, we're talking about Kafka, right? To scan all of that as you similarly, that's fast. How would Avro excel in this example?
Yeah, so when you have the container format, the schema is going to be in there, so you would never need to use the generic API for it. Reflection and the generic are just additional options for that. But if you have the schema, which you would in a big data scenario, that's essentially what you use. Whenever possible, the schema is available, you should use it. The schema is not around, or like I said, just in case that you're trying to pull a couple of fields off of the thing, it's just flexibility. It definitely is a lot slower. When I say quickly, I'm not like quick and dirty, like I just want to pull data out or not quickly, like my application performing quickly, just from a productivity perspective.
So, actually, we're going to conclude this one, but you guys can stick around and ask some questions separately. So, just want proceed with your questions now if you guys want to continue.
Is giving a warm